parallelism. In this video, we'll talk about how to work with parallel vectors. So, if you remember from geometry, parallel means two things have the same slope. It's the exact same thing for vectors. Vectors have the same slope, so they're going the same. If you look at these, like the direction they're going, like the angle they make, are all the same. They're all different lengths, but we don't care about that. All parallel cares about is the same slope. So if you have two vectors, if you have two or more vectors going the same direction, like we have here, they're considered parallel. So by definition, two non-zero vectors are parallel if and only if one's a scalar multiple of the other. So what does that mean? Well, if you have a vector, that lets you know which direction it's going. Well, like the values let you know which direction it's going. If you multiply by a scalar, which remember in vector just means a number, so I just do like 2 times that vector, it's still going to go the same direction, just longer. So these will still be parallel. So two vectors are parallel. If you have a vector, you can multiply by any number you want, and they'll still be parallel. So that's what it says here. If A is parallel to B, then there exists a scalar K such that A equals KB. That right there is a definition of parallel vectors. If you have a vector, multiply by any number you want, and you get the other vector that is parallel to the first one. So notice it's just a random K. It could be anything. It can even be negative. So if I multiplied like my A by a negative value, that's not the best drawing. It's supposed to go the same direction. It's a little off. But the idea would be that even if you're going the opposite direction, it's still making the same angle. Just it's going the opposite direction. So those are also considered parallel. So this right here is a general idea for parallel. If you get a vector and you want something that's parallel to it, multiply by any number you want, and then you get the other vector, and those two things are parallel. So for a quick example before we move on, let's say I say vector B is 2, 1. If I want to example something that's parallel to this, I can do a vector C that's, well, first you can multiply any number you want. So let's multiply by 3. So to get 6, 3. Those two be parallel. I can multiply by a negative number, like -4. So I get -8, -4. Those two be parallel. And I can multiply by 1. And I get 2, 1 again. This is actually the most popular version. A lot of times when they say draw something as parallel, a lot of people just use the exact same vector. That's considered parallel. Your K is 1. So all these are parallel. As long as you get your original function and multiply by any number you want, those two will be parallel. With that in mind, let's look at this one. Find R and S given that A is parallel to B. So they're parallel. I know that if I multiply these guys by some number K, I get this one. So let's set that up. I have like 2 times K equals S from the top. From the middle, I have -1 times K equals 2. And then from the bottom, I have R times K equals -3. Right, that's the way it works. If you multiply this vector by some value K for all of them, you get this parallel vector. So there's only one of them you can actually solve, and that's the middle one. How do you go from -1 to 2? Well, if you're not sure, you can divide by -1. You get it by multiplying by -2. So that's the factor. If you multiply by -2, you get over there. So what does that mean? Well, if my A is 2, my S is going to be multiplied by -2, -4. You can also, since you know K is -2, just plug it in and you get -4. Same thing here. Plug in and get your value. If this is my R and I have to multiply by -2 to get 3, then I should divide to go backwards. Or you have the formula right here, just plug in K equals -2. R times -2 equals -3. R would equal -3 over -2, or 3/2. And S was -4. So that's how you do it. If it's parallel, that means you multiply everything in this vector by a certain number to get this vector. Find the one that you can actually solve. So in my case, it was -1 and 2. So multiply by -2 to get to this side. Then multiply to get there, and divide to get back here. Or set the equations. Unit vectors is actually a little bit of a review. I've talked about before, a unit vector is just a vector with the magnitude of 1. So how do you find a unit vector? If I give you a thing, all you do is this right there. Get the vector we're talking about, and divide it by its magnitude, right? The length of that vector. So if you get a vector divided by its magnitude, you get a total vector value of 1. So that's how you do it. Again, this is the format that's not in your formula sheet, but we should just kind of know it anyway. So you get the vector and divide by its magnitude, and that'll give you a total value of 1. What if I want a vector B in the with the length of k in the same direction as a. So all that means is this. Find your unit vector right here, or in my case, it's find the unit vector of a over the magnitude of a. But you want it to be a length of k, so well, this has a value of 1 now, so it's multiplied by k. That's all we ever do. Find the unit vector form, and then times by whatever value I want. Find a vector of b length of k, which is parallel to a. What's the exact same problem just now? Since parallel can be either positive or negative, so make that k positive or negative. You're good. So let's do an example. If a is 3i minus j, find a unit vector in the direction of a. So remember that formula is the vector divided by its magnitude. So we gotta find the magnitude of a. You see the magnitude formula where I just use the components to the a squared plus b squared equals c squared. So I get this. I get radical 9 plus 1, which is rad 10. So a unit vector in the direction of a would just be 3i, sorry about that, 3i over rad 10 minus 1j over rad 10. That's a unit vector in the direction of a, right? Because my vector a here has a value of 10, rad 10. So if I want a unit vector, just divide by the magnitude, rad 10, rad 10. A vector length 4 units in the direction of a. So right now this has a value of 1. It's a unit vector. So if I want a value of 4, so I can multiply this by 4. So that's going to be 4 times my answer from a. Not pretty, but just distribute. And then that's like 4 over 1. So you get 12i over rad 10 minus 4j over rad 10. Remember in IB, we really don't care about rationalizing. This is a perfectly fine answer. Vectors of length a, 4 units, which is parallel to a. So remember, I've said this before, if you want parallel, the easiest way is just copy it. It's the exact same answer. So I want a vector of length 4, that says length 4. It used to be length 1 and multiply by 4. In the direction of a. This goes in the direction of a. Right, parallel means you just multiply this answer by any number you want. Most people just multiply by 1. That's the easiest answer you have. Since technically these are parallel to each other, they're going in the same direction. So you get that. Or if you want to be more fancy about it, multiply this by any number you want. I don't know, 3, 36i rad 10 minus 12j rad 10. And that's how you find a unit vector in the direction of a certain value. Okay, let's go to this last example real quick. Find a vector b of length 7 in the opposite direction of vector a, right here. So I want it to be b in of length 7. So first opposite direction. So my b is going to be the opposite direction of that. So it's going to be negative a, which is going to be negative 2, 1, negative 1. And I want to have a length of b. Now I don't know what the length of this guy is. Sorry, length of 7. I don't know what the length of this guy is, but let's find it. The magnitude of that is going to be negative 2 squared plus 1 squared plus negative 1 squared. So I get 4 plus 1 plus 1. So I get rad 6. So the length of this guy is rad 6. But I want it to be a length of 7. So remember the way we talked about it? Just make this a value of 1, and then we're going to times it by 7. So I'm going to find the unit vector in this segment. So multiply that by 1 over rad 6. That way it gets negative 2 over rad 6, 1 over rad 6, and negative 1 over rad 6. So that's the unit vector of a, right? So we found out the length of this was rad 6. I divided it by rad 6, and it has a value of 1. I want a value of 7. So that's simple. Multiply everything by 7. Distribute. Remember it's like 7 over 1, so I get negative 14 over rad 6, 7 over rad 6, and 1 over rad 6. 7 over rad 6, negative 7 over rad 6 is what I meant to say. And that is a unit vector in the opposite direction of a with the value of 7. Right, remember again, so how did I do that? Well, I first figured out what the value of this was. Magnitude, rad 6. So I want a value of 1 so I can make it 7 later on. So opposite direction, flipped it. Now multiply by 1 over the magnitude. Alright, our trusty formula to find the unit vector. So I get this vector here, which has a value of 1, and then multiply by 7. So you get a value of 7. That's it.